Hello everyone, let's welcome to my channel. Here we are, the question is, let A is a matrix. They have given it the matrix of 2 cross 2 order and the elements are 0, 1, minus 1 and 1. Then the smallest positive integer. We have to find the value of n which is going to satisfy the condition. What is that condition? A raised to n must be equal to identity. So at what value of n you are going to get the value of a raised to n should be your identity matrix. So it means that how many times you are going to raise the power of your a so that you should get the identity matrix. So we have to find out this n value. So for that the matrix is given to you. First of all we have to find out the characteristic polynomial of the matrix. How you are going to find out the characteristic polynomial of any given matrix? With the help of this. That is, we can easily find out the characteristic polynomial of any given matrix with the help of this. That is a determinant of a minus lambda I. So here a is your matrix and I is your identity and lambda is your eigenvalue which we have to find out. So here we have to multiply the lambda with each element of the identity matrix. So here first of all, to take the determinant of a minus lambda I, we have to find out the a minus lambda I. So what will be the a minus lambda I? So it will become minus lambda 1 minus 1 and minus 1 minus lambda. So just take the determinant. So after taking the determinant, you are going to get the value, that is minus lambda plus lambda square plus 1. So here this is your characteristic equation. Okay, so first of all, if you want to matrix is given to, in this question the matrix is given to you, you have to find out the characteristic polynomial. So here we got the characteristic polynomial, that is this is your characteristic polynomial, that is minus lambda plus lambda square plus 1. So what will be the characteristic equation? Characteristic equation will be the lambda square plus lambda plus 1. It will become equal to 0. Sorry, it is minus lambda. Here you are going to get lambda square minus lambda plus 1 is equal to 0. This is your characteristic equation. Now take this term, this whole term to this side. It will become, in left hand side, in right hand side it will become lambda square equal to minus 1 plus lambda. Okay, so here we got that lambda square. What is the value of lambda square? Lambda square is equal to minus 1 plus lambda. Okay, then, and we know that theorem that every square matrix must satisfy the characteristic equation. What it means? The matrix is given to you and that matrix should satisfy this equation. That is your characteristic equation. It means that instead of your lambda, you have to substitute the value of the matrix A. So here it is a lambda square is there, so it will become A square, because every square matrix must satisfy the equation. So then minus 1 became your identity matrix. Okay, then this lambda became the matrix A. Every square matrix must satisfy characteristic equation. It means the lambda will be changed to your matrix A and the minus 1 will change to your identity matrix. Now here we got the value of A square. When the n value became 2, here we got the A square value is minus I identity plus A, but we haven't got the A raised to n, we haven't got the equal to I. N is your natural number, that is a positive integer. It may be 2, it may be 1, it may be 3. So here for n equal to 2, I haven't got the identity matrix. I got minus identity plus A. Now multiply the A on both sides of this equation. What you are going to get? A square into A, it will become A cube. Okay, and multiply the A with right hand side, it will become A into minus I plus A. So A into minus I, it will become minus A, and A into A, it will become A square. So here we got that A square equal A square minus I. Here we got the value of A cube, A square minus A, and substitute the value of A square. What is the value of A square from this equation? Minus A minus identity, we can write it as A minus identity. So substitute that value, it will become A minus identity minus A. Now a and minus a will get cancelled, the remaining term will be minus I. So here we got the value of a cube, that is your minus I. Here the n value is 3, but here we got the negative of your identity matrix. But what we want? We want the identity matrix. So for option A is also wrong, because a raised to 1 we are getting the matrix which is not equal to identity. For a equal to 2 we got that minus I plus a. For next option we have to check for the 4 and the 6th. Now multiply the matrix A on both sides of this of equation. Here we got the equation that a raised to 3 is nothing but minus I. Multiply the a on both sides of this equation, it will become a raised to 4 minus a. So here a raised to 4 value is minus a. Still we haven't got the identity. Now multiply here we got the equation that is a raised to 4 equal to a. Multiply the a on both sides. What you are going to get? A raised to 4 into a, it will become a raised to 5, and here we have already minus a is there, minus a into a, it will become minus a square. Keep minus I as it is. What is the value of a square? The a square value is minus I plus a. Substitute that value, it will be minus of a minus identity. You take it this minus to inside, it will become minus a plus I. Still we haven't got the identity. So here we got the value of a raised to 5 is minus a plus I. Okay, then multiply the a on both sides of this equation. Again here a raised to 5 is already there. If I multiply with a, it will become a raised to 6. Okay, then multiply with a to this also, it will become a into minus a plus identity is there. So a into a, it will become minus a square, and a into I, it will become a. So here what is the value of your a square? Substitute. Minus will be minus a square is there, and just substitute the value of a square. So the value of a square is a minus I identity matrix, or I minus I plus a. Just substitute it. So minus will be as it is. Just substitute the value of a minus a square, that is the a minus identity plus a. Now take this minus 3 inside, it will become minus a plus identity plus a. So minus a and plus a will get cancel. What you are going to get? At a raised to 6 we got the identity matrix. It means at n value, when the n value is 6, we are getting the value of a raised to 6 becoming the identity. It means the n value is 6. The option D is correct.